preventing file-based botnet persistence and growth. So, Kurtis, you have the floor.
Thank you. All right, so let's just jump into this. So a bit about myself. I'm Kurtis Armour. I'm an information security consultant at eCentar Incorporated. I've been working in the security community for about 5 years, and this talk is based off of my personal research. My day-to-day is a vulnerability management consultant and also a pen tester. I enjoy finding ways to help build more secure networks and try and help our clients have a better structured defense against malware attacks. So paying some respect here, there's a lot of people that helped me prep for this and a lot of research that went into this. So Chris Losa and Jacob Gacek are two security researchers that I work with. And Matt Greber has done a lot of research on AppLocker and Device Guard. And he's done a lot of bypass research as well. So there's a lot of good research coming out of these guys. So check them out for their latest work. Okay, so the goal of this talk is to talk through some of the defensive configuration options that people with Windows operating systems have available to them. Obviously, there's no silver bullet to protecting against specific attacks, but if we layer enough defenses, it makes it a lot harder for people to get onto systems. Education of the threat landscape. So I'm going to show examples of common execution methods for droppers and payloads. If you have the ability to stop a dropper before it gets the payload onto the system, you effectively can stop a breach. And the majority of this talk focuses on post-exploitation. So someone who has the ability to get a dropper onto a machine, but then stopping that dropper from being able to execute. So layers of protection, we always talk about this in security. So one solution is not going to fix all your problems, so you want to layer multiple solutions on top of each other to make it more complicated for someone to breach your system and to remain on your system. And in most cases, blocking these attacks before they hit the host is the best way to protect yourself so that you're not dealing with all these bypasses and nuances on the host-based system. So things that are not covered, I'm not talking about IoT-based botnets at all, so no Linux malware, no embedded device malware. Obviously with fileless based attacks, nothing is touching disk, so there's not much configuration protections you can do against that, so I'm not going to touch on that. As well as shellcode-based attacks, because of how they can be invoked, I'm not going to talk about that either. Okay, so this is kind of just following the trend of all the talks. The main delivery mechanisms for botnets and malware generally is through social engineering. And it's typically tricking the users into clicking on emails, doing things that they're not supposed to be doing on a computer. And in a lot of cases, execution of faked files or hidden files that seem to be something that they're not, resulting in compromise. And the end goal of most threat actors is monetization, and for bot herders, it's building your botnet and getting it to a larger state. So another common technique for getting onto a system is through exploitation. So this is through generally malvertising and exploit kits, which targets browsers and third-party applications. Flash is one of the most commonly exploited ones, so I always like to include this picture to represent that. And EKs can drop any variant of malware. So it could be something that's attaching to a botnet, or it could be Locky or some other strain, but it really depends on who the EK owners are, what specifically they're dropping. So really you want to be able to stop the majority of the attacks so that you cover yourself from being part of any of the botnets or attacks. And so historically, we've seen the majority of the attacks from EKs are file-based, but we have seen file list-based attacks. So I'm going to be specifically looking at the things that you can do to stop file-based attacks. So let's talk about some droppers and code execution. So the end goal for most threat actors is to get their malicious code executed on your computer. And what are the main ways to execute code? Well, you got binary executables, interpreted code, scripts, and shell code. So like binary code is EXEs, DLLs, MSIs, scripts, JavaScript, VBA, VBE, WSF, and PowerShell. That's some examples. So this isn't a comprehensive list, but it's a list of some like fairly common droppers that we're seeing utilized by threat actors. So, you know, HTML and HTA files, JavaScript, zip, 7-zip, RAR, which includes generally a packed JavaScript inside, EXEs, DLLs, MSIs. Document macros is a really big problem, which we've touched on in the conference. PowerShell is really powerful and has a lot of issues with controlling it, and then VBA, VBS, and PDFs. So let's look at some of these execution trees. So in this example here, there's a document macro that drops a binary, and then it executes it, and then bad stuff happens, right? This example here, Tom touched on this briefly. I think we were using a very similar sample, but it's a document macro which executes cmd.exe, which then executes PowerShell. PowerShell downloads and executes the executable. The second one is an HTA file. So some cool things about HTA files is that it does not use the in-host script interpreter. It uses its own script interpreter, which is mshta.exe. So if you block a script interpreter on the host-based system, they can still execute the mshta. So in this example, it executes the HTA file, builds the VBS file with an echo, and then executes the VBS file, downloads and executes an executable at the end. And in the last example, this is an EK that hits Internet Explorer. So Internet Explorer goes to a site, it gets loaded some Flash content, that Flash content gets exploited, then it echoes the scripts, WScript builds and downloads the payload gets executed, bad stuff happens. So in most organizations, your main goal should be preventing malicious code execution. If you can prevent malicious code execution, then you're winning. So as I said before, the goals of adding layers is to make things more difficult. The more things that you strap on, the harder it is for someone to bypass all of the security layers that you have. And the main goal is to stop the auto execution of bad content. So things like when someone double clicks on something, you don't want that to execute and be able to do whatever it wants. Blocking of the execution of code can be done at different layers. So as you saw in those process trees, there's a bunch of different things that happen after you initiate the initial dropper or the initial macro. So like at each of those layers, if you have some sort of security controls, you can effectively stop it before it gets to the end payload. And pushing out configuration changes through GPO is the best way to make sure that the majority of your organization has these protections and that they're secure and being followed. So not giving threat actors direct admin access when they initially pop the box is we don't want them to have immediate unrestricted access if they are to get some code to execute. So you want to make them do other things. You want to make them escalate their privileges. So it's potentially something else that you can detect and stop. If you know what software is on each of your computers within your organization, then you know what your potential susceptibility is to certain attacks. So if your organization is not using Java, then you know Java-specific EKs are not going to be targeting you, so that's one less thing that you have to worry about. As well as if people don't have the ability to install software, you don't have to worry about rogue software being installed and then potentially opening up more vectors for attack. A really cool tool that Microsoft puts out is called Local Administrator Password Solution. And so in most domain environments, you have to be able to randomize the local administrator account on all the machines because if one of your machines gets popped and it's the same local administrator password across your organization, then lateral movement is pretty easy because that's what someone's going to try and do once they get the local admin password, is to try it across the organization. So this is a good way to manage that within an organization that's using a domain. Okay, so let's talk about the Windows script hosts. So the Windows script host is used to interpret and run plain text JavaScript and VB script files, as well as Windows script files. It uses C script and W script for the interpreters. And if you were to double click on a JavaScript file or a VBS file by accident or got tricked into doing it, that would execute through the Windows scripting host. So this is one of the main ways that we've seen Locky and a lot of ransomwares being distributed, is by tricking people, double clicking on it, then having it execute. So you can actually disable the built-in support for this, so that when you double click on it, it actually just throws an error saying, hey, your administrator restricted this from being run. And it's always important to keep in mind that host hardening is specific to the organization. So just because one thing works for one organization, it may not work for another organization. So like, I know there's a lot of people at banks that have legacy scripts, like that use W script and C script to push out specific updates across the organization. So obviously disabling that would not work for them, but there are other ways of defending against this. And you can also change the default program execution. So you can make it so that instead of running it through an interpreter, it opens in Notepad. So here's an example of one registry key that you can change so that it does not execute by default when you double click on a JavaScript or a VB file. And it's important to note that you have to do this both for 64-bit and 32-bit because Windows is awesome. So I did some testing and EKs were still landing, and then I found out, hey, there's a second one that you have to block as well. And that's under syswoe 64, so those of you. And then obviously changing the default execution of the program. You can do this in the back end, but you can also do it through Explorer as well. All right, so let's talk about Microsoft Office files. So almost all Microsoft Office files can contain embedded code written in Visual Basic. These are obviously called macros. And the Microsoft Office macros use their own interpreter. So on install, it installs its own DLLs, and that uses that to interpret the Visual Basic script. And we obviously want to stop users from executing untrusted macros because macros are a really consistent way of being able to get code execution. And there are configurable macro rules for Office, which includes Excel, Word, InfoPath, Outlook, PowerPoint, Project, Publisher, and Visio. Obviously, the most common ones we're seeing is for PowerPoint, Excel, and Word, but all of these applications actually have the ability to have macros configured for them and disabled. So this is a chart of some configuration recommendations related to security policies. So disabling macro policies is only effective if you can turn off the security notifications. Disabling it and allowing someone to re-enable it because they get tricked by an image that says, hey, re-enable this document, it's not really good security. So you want to make sure that you confirm that there's no notifications for when macros get blocked. Also, a problem is when you only allow digitally signed macros, the user actually has the capability to trust an untrusted digitally signed macro. So if someone signs it and sends it, then a user can be like, I trust this because I recognize this publisher, which obviously is stupid. So there are some cool new features that have been released for Office 2016. So it provides more granularity to apply policies through GPO. This wasn't really supported before, and now it is. So yay, Microsoft. Trust Center has some cool new stuff. So you can restrict the ability for users to allow macros. So that notification that says, hey, there's a macro in here, you're not allowed to run it. That can now be turned off, or sorry, you are allowed to run it if you click this button. That can now be turned off and restricted so that they can't be tricked into running that macro. And also you can restrict the ability for macros to be run from the internet. Another one of the features you can use is trusted location. So if you are using a trusted location within your corporation, you want to make sure you limit who has access to put files in there and execute files from there, essentially. Okay, this is the fun part. So PowerShell has been used a lot recently for fileless exploits and a lot of building of payloads and downloading of payloads. Most organizations don't really have a tight control on PowerShell, and it's definitely not an easy thing to do. And the reason PowerShell is so dangerous is because run code in memory without touching disk, download and execute code from a remote system, interface directly with .NET and Windows APIs. And the older versions of PowerShell don't provide as much logging for people to be able to investigate and watch it within an organization. So blocking this functionality is definitely not easy. There's a few things you can do. You can try blacklisting the PowerShell.exe. That does an okay job, but you're going to break some of the functionality in PowerShell, as well as there's bypasses, obviously. So the PowerShell.exe is just a wrapper for the PowerShell interpreter. So if you're able to import the backend of PowerShell, you can just initiate those commands. There's a lot of bypasses around that. Local security policies is not the answer. If you restrict PowerShell through a local security policy, that stops it from being able to be called through Explorer. If you are issuing commands through cmd.exe, you're still able to get them to execute, as well as if someone gets on the system, they can change, obviously, the settings on that. Execution policies as well, they're not really a security feature. They're very easily bypassed, and they shouldn't be used to try and constrain the execution flow of PowerShell. So PowerShell version 5 came out. It has a lot more features in it. So it provides improved logging. So there's a lot more logging, and it's a lot more granular. And it also improves security features. So it does script block logging. It does system-wide transcripts. There's a constrained PowerShell feature, which I'll talk about, as well as in Windows 10, there's an anti-malware integration mechanism. So it'll scan PowerShell scripts before it executes them. So constrained mode is one of the best ways to limit the attack surface of PowerShell within your organization. It limits the ability to direct .NET scripting, invoking Windows 32 APIs, and interacting with COM objects. So most PowerShell malware, as well as PowerShell pen testing tools, get broken when you're using this. But deploying these fixes and configurations will also create issues for you, but you can have signed PowerShell documents internally that you trust, and then those will execute normally without being constrained. Yeah, so this is one of the better recommendations, and depending on how you deploy it is how secure it is. So there's ways of deploying it with AppLocker to make it more secure, as well as with Device Guard to make it more secure, so there can't be any changes made to it. Okay, so I'm going to talk briefly about some application whitelisting stuff. So I focused on AppLocker just because it comes free with some versions of Windows, and it's one of the basic ways of implementing application whitelisting in Windows. And its policies maintainable through GPO. I already said all this stuff. So in the features that it provides is for application inventory, protections against unwanted software, as well as software standardization. And this has been available on system, a deprecated version of this has been available on systems under the software restriction policies. It's just not as granular as PowerShell, and it's a lot harder to implement like per group in a domain. So AppLocker has that ability to be more granular. So there's two main approaches to implementing app blocker. There's an allow mode, which is obviously the most secure, but it's very difficult. Well, it's more work to initially set up. So you block everything by default, and then you whitelist things that you know are legitimate. And then there's the deny mode, which is allow all, and then blacklist bad things, but obviously that's not as secure. App blocker also provides the ability to enable audit features. So you can build policies and put in an audit mode, which will then log to the event manager, and then you can see how your policies are going to do. So obviously with application whitelisting, a lot of testing has to go into it. So you want to make sure that your system is set up to work with your policy, and then you want to put some malware on, a system that's dirty, and then keep testing to see where your policy fails and continuing to improve on it. So the filters are for hash, path, and publisher. Publisher is generally the strongest because someone has to steal someone else's certificate to sign it from them. So if you're trusting like Microsoft, Adobe, and other products that you have in your organization, I would recommend you use publisher over path and hash. So if you are not going to put it in an allow mode, block everything and allow by default, you're going to want to make sure that you're at least blocking the ability for people to execute code in the OS Drive users folder. And obviously, you're going to have to put in a lot of publisher rules for that because this is going to break everything that's installed in programs file. There's also default policies that AppLocker will push out when you're doing your base policy. So it's going to trust, stuff that's executed in the Windows folder, stuff that's executed in the programs folder, but it's not going to trust things that are dropped in temp app data or other places where we commonly see malware. So publisher rules, really important. You'll notice if you do this blocking that Google Chrome will no longer work unless you trust the Google Chrome publisher. So you'll have to go through and see all the different technologies that you have deployed and then have that updated. So with the base policies of AppLocker, there is some inherent privileges that are given to some folders within Windows and System32. So I'll talk about those in the next slide. And there's a cool feature using the automatic generation of executable rules you'll point to a specific place on the computer, and it will auto-generate publisher rules, it'll auto-generate hash rules, so that it makes the deploying of this easier. But obviously, this is going to have to be something you work and tune to make it effective within your organization. So here's a list of some Windows and Sys32 folders that have some inherent permissions. So in some versions of Windows, you actually have the ability to put files in here. And with a default app blocker policy, if a threat actor was to drop a file in here instead of in the downloads temp folder, they would be able to execute code with the default app blocker policy. So when you're putting in rules, you want to make exceptions for these folders to make sure that no one is able to execute out of these folders that have inherently less permissions tied to them. So if you want to not trust your users to not go through and allow macros for Microsoft 2013 and below, you can actually block it on the back end. So AppLocker has DLL blocking, and you can effectively just block the VBA DLLs, and they will not load and they will not be able to execute macros. The same sort of thing can be done for PowerShell. The backend of PowerShell has a bunch of different DLLs. If you block each of those DLLs, it will no longer be able to be imported. HTA files I talked about before are really nasty. So if you do all those Windows scripting host changes, an HTA file will still execute because it uses a different interpreter. And this is one of the main ways that pen testers get code execution on engagements, at least some of my team does. And I talked about this briefly before. If you block the PowerShell.exe, it has some auto execution stoppage capability. So the malware authors that call PowerShell to execute other commands or download malware, that'll be stopped. But you're also potentially going to break systems, the inside of the systems. And because we're moving to PowerShell for like the command line for Windows, in the future, this likely would not be sufficient. So I always recommend, like, I've always been told that constrained language is your best bet to securing and locking down PowerShell within an organization. Okay, so talking about some bypasses and ways to get around this type of stuff. So app blocker is obviously configurable locally. And if you were to get on and get admin access to that machine, you can just create rules that says, hey, you're allowed to execute everything. It's no good. Also, admin has the ability to turn off the actual app blocker service, which investigates every executable before it launches, which would make it ineffective. And speaking to the research that I was talking about before with app blocker bypasses, Matt Greber has done a lot of research on MS Builder, CDB.exe, DNX.exe. You can pass these legitimate signed and trusted Microsoft binaries code, and they will execute it for you. So ways of getting around this is Device Guard. Device Guard is pretty much a beefier version of AppLocker and is newer, and it has more protections around making sure that signed code can't be doing things that it's not supposed to be doing. Oh, right, and if you were to install the latest version of PowerShell, your old PowerShell is still going to be there. Threat actors know this, and they can call the old PowerShell. So if you're doing constrained language support for PowerShell version 5, you're either going to want to uninstall the old PowerShell or make sure that it also has constrained languages. And also, if you're logging PowerShell version 5, PowerShell version 2 is not going to log to the same place unless you configure it to do so. And putting AppLocker in allow mode automatically sets PowerShell to constrained language in version 5. So just a quick thing on Device Guard. Essentially does not allow untrusted code to be executed. Everything is untrusted by default. And there's two primary components, code integrity checking, which so there's kernel mode code integrity, which protects the kernel mode from running unsigned drivers. This has been around for a while in previous versions of Windows, but the newer one, which is user mode code integrity, enforces user mode code integrity on binaries, PowerShell scripts, WSH scripts, and MSIs. And VBS is the system that protects it from being changed when it's running. So in conclusion, adding layers makes executing bad code harder. We want to add as many layers as possible while trying to keep an organization still functional. There is no silver bullet to defense. You have to layer based on network and hosts. And once you add all these layers, making it too complicated for the attackers, they'll go find someone else, hopefully. And not every company is the same. So one fix or one deployed solution that works for one company is not going to work for every company. So you have to be able to, figure out what your needs are in your company, what your exposure is, and then deploy specific fixes for it. And that's pretty much the presentation. Thank you for listening.
Okay, so now you're protected. Questions? On. You're all safe, you don't need that?
Coming.
I'd like to point out that it says more secure, not secure. My slide up there. How many of you guys have heard of Device Guard and have looked into it? Oh, Tom, what's going on, brother?
Kurtis, thank you very much for this great presentation. Something that I didn't see in your slides, the path program data, I think is writable for normal users as well. So that's probably one of the paths that hasn't been listed or mentioned in your slides. Besides the users and the certain directories under Windows, program data is something that I see commonly used by malware infections where they drop code as well.
Yeah, are you talking about app data temp?
No.
No? Okay.
Program data. There's like program files folders for like 86 and without the 86, there's 2 locations program files and there's one program data.
Yeah, there's
under the root.
Yeah, so there's also tools from sysinternal that you can run on your operating system, and it will populate all of the folders that your current user has permission to access. So like within your organization, you would want to run this and then see which users have access to which folders, and then make that specific to your organization.
Yes. Great presentation.
Cool.
Thank you.
There a question left upstairs?
Malware Tech, if you're here, I know you know about device guard.
Vlad. Yeah.
Hi, my question is for the public. Does anybody here know a client or a company that use, let's say, just half of all the recommendation here? 3, 4, 5? Okay.
Oh, we have more work. Okay. Okay, thank you.